Okay, in this video we're going to look about a lift going up a tall building. So it says a 6-ton lift travels at 530 meters in a tall building and takes exactly 60 seconds to ascend. A group of 12 people with an average mass of 75 kilograms are carried up to the top of the building. The lift takes 8 seconds to accelerate uniformly to a constant speed, which it maintains until it decelerates uniformly to stop at the top of the building. In the first stage, the tension in the cable is 76,245 newtons. A. Find the acceleration of the lift in the first stage. B. Sketch a speed time graph of the ascent and hence find the constant speed and the time the lift is travelling at the constant speed. C. Find the deceleration as the lift reaches the top of the building. D. Find the tension in the cable when the lift is travelling at a constant speed and decelerates, hence state which part of the journey the tension is a minimum. And E. Just before the lift stops, one person experiences an upthrust of 536.8 newtons from the floor of the lift. What was the mass of the person and their upthrust when the lift initially accelerates? So quite a long involved question here. Okay, so drawing a force diagram, which is essential in this sort of type of problem. So we've got our lift, we've got an acceleration because the lift is going upwards. We have a total mass. Now the total mass is going to be the 6 tons, which is 600 kilograms, plus 12 times 75, because the average mass of these 12 people is 75. That gives me 6,900 kilograms. We've got 600 and then 900 times G acting downwards, the force acting downwards, and the force upwards will be the tension, which is 76,245 newtons. So using the equations of motions, as it's going upwards, we have to do T minus mg, which is this one here, is got to be equal to m times a, and we're using Newton's second law of motion here. So we've got 76,245 minus 6,900 G is equal to 6,900 times the acceleration, what we've got to find. So this, when we work this out, comes out to 8,625 is equal to 6,900 A, and therefore A will be equal to 1.25 meters per second squared. Right, now we've got to sketch a speed time graph of the ascent. So we know the acceleration is 1.25, and we've got to find the constant speed and the time the lift is travelling at a constant speed. So sketching a speed time graph. So set of axes, time and speed. It's only a sketch, so it doesn't have to be accurate. So we're going to have some sort of acceleration for 8 seconds. We're going to travel at a constant speed to just before 60, and then just this last part is going to decelerate. So the graph would look something like that. Right, we got to find the value of v. So we're using v is equal to u plus at. So the initial speed is 0. The final speed we need to find, and the acceleration we know to be 1.25, and we know it does that in 8 seconds. So we need to do v is equal to u plus 1.25 times 8, which gives me exactly 10 meters per second. Right, we now need to find this distance here, the time travelled at the constant speed. So using the idea that the total distance travelled by the lift is going to be 530 meters. So the distance is the area under the graph. So we have a trapezium here. So using that idea of a trapezium, so this distance t plus 60 times my height, which I now just found to be 10, divided by 2 has to be equal to 530. So I need to solve that. Multiplying by 2, I'm going to get that t plus 60 times 10 is 1060. Then t plus 60 must be 1006, therefore t must be 46 seconds. The lift will travel at a constant speed for 46 seconds. Right, we now have to find the deceleration for the last part, so we can either use the graph. We know that this here is going to be 54 because 46 plus 8 makes 54, so this last part here will be 6 seconds. It decelerates for 6 seconds, so using that idea, we want the final velocity this time to be 0, u to be 10, the time is 6, and the acceleration is a. So that gives you that a will become minus 10 divided by 6, which is minus 5 over 3 meters per second. Okay, so the deceleration will be minus 5 over 3 meters per second squared. Okay, so the constant speed, so part D, was find the tension in the cable when the lift is travelling at constant speed and decelerates. Hence, decide which part of the journey the tension is a minimum. So we find the tension in the cable. So we've got the tension in the cable at constant speed. We've got a mass or a weight of 6,900 times g acting downwards. V will be 10 meters per second, and there's constant velocity. There's no acceleration. So we can say that T minus 6,900 g is equal to the mass times 0. So it's going to give that T minus 6,900 g is equal to 0. Therefore, T will be the same as the weight acting downwards, which is 6,900 times g, which is 67,620 newtons, taking g to be 9.8. Right, deceleration. So in the deceleration stage, we've got the T acting outwards and the 6,900 grams acting downwards. This time we've got an acceleration, though, of minus 5 over 3 meters per second squared. And the minus sign is quite important. So we're going to have T minus 6,900 g is going to be 6,900 times our acceleration, which is minus 5 over 3. So T minus 6,900 g is going to be minus 11,500, and that's going to give that T is 56,120 newtons. Now we had 76,245 newtons at the beginning, with a constant velocity 67,620 newtons. Therefore, this one here is the minimum. Therefore, the minimum tension will occur as the lift decelerates. Okay, so if you're not sure in a question, you could very quickly work out each stage what the tension should be. Right, just before the lift stops, one person experiences an upthrust of 536.8 newtons from the floor of the lift. What was the mass of the person, and what would be the upthrust as the lift initially accelerates? So now we draw force diagrams on the person. We're going to let the person MP be the mass of the kilogram of the person. So we've got our person, we've got a weight of mpg acting downwards, and a reaction with the floor being R. We're told that reaction is 536.8 newtons. We are in the last part of the journey, so the acceleration is minus 5 over 3 meters per second to the minus 2. So drawing a diagram is very, very important. So the equation of motion will be R minus mpg, the mass of the person times the gravity, is equal to the mass of the person times the acceleration. So 536.8 minus mpg is going to be mp times the acceleration, which is minus 5 over 3. Right, if we can now say that 536.8, if we take this over here, we're going to have, and take mp out, we're going to have mp is g minus 5 over 3. Pause the video if you're not sure about that and check it for yourself. And therefore mp will be 536.8 divided by g minus 5 over 3, taking 9.8 as g. That will give the mass of that person is 66 kilograms. Now we have that situation. Now what was his upthrust in the initial part? So it's the similar sort of diagram, but we now know that's 66 g. We want to find that reaction, but our acceleration, we're going back to the first part of the question, so the acceleration is 1.25 meters per second squared. So we've got R minus 66 g is equal to 66 times 1.25, and therefore we're going to have R is 729.3 newtons would be his the upthrust as he experiences as the lift initially accelerates uniformly. So this has been a video to look at the motion or the forces acting on a lift. I hope you've understood, and I thank you very much for watching.